Okay guys, so we're going to look at what are addition polymers. So addition polymers are formed by linking alkenes, hydrocarbons with our double bonds in, together to make long carbon chains. So you can take any alkene and do this, react them together, break the double bonds to make your long carbon chain. They are mostly used to form different types of plastic. So things like PPE, PVC, polyethylene, PP, polypropylene, etc. are all made from an alkene. They're all addition polymers. And if we change the alkene, you can change the property of your plastic. So polystyrene, for example, is used to make carrier bags, whereas polypropylene is used to make food, like takeaway food containers. So making a slightly different alkene into the plastic changes the property of your plastic. We call them addition polymers as we're linking them by breaking the double bonds together, and we form one product. So like our bromination reaction, alkenes, when we did the reaction with bromine, it was an addition because we added the bromine to the double bond. Same idea here, we're adding another alkene to the double bond, so we end up with one product. Nothing falls off of the molecule at any point. When we do addition polymerization, we call the alkene by itself the monomer. Okay, so you have one of them. That's the idea. So in this case, my monomer would be ethene. Okay, so this would be called our monomer. And the polymer is the long chain formed from the monomers. So in my mixture, if I have some ethenes, I can form my polymer because they're unsaturated. I can break the double bond, which can then cause this one to break, and they join together. And then that causes this one to break, and they join together. And we end up with a long chain, no double bonds anymore. We've just linked them all through by the double bonds. And this can happen hundreds of thousands of times. Okay, so you can have hundreds of thousands of ethene molecules joined together to make your polymer. This can be done, like I said, with any alkene you wanted. So if I had propene, so here's my propene with my 3 carbons and my double bond, exactly the same thing would happen. So you would break the double bond like this, and this would cause the next double bond to break, and they would link together. Now notice, guys, by doing this, I now have a CH3 group hanging out the side. Okay, this is my chain along here. These groups, the CH3 group, so the group that's down here, not part of the double bond, cannot join in that chain. It's already saturated. It can't get into that chain because it's already got its 4 bonds. So it's going to stick out alongside the chain. So our ethene has nothing but hydrogen sticking out because there was no other carbons than the ones in the double bond. But with our propene, we're going to end up, as you can tell by the different coloured bonds, with something sticking out, and then we can attach our last one. And now you can see there are 3 grapes sticking out. Okay, 1, 2, 3, because they can't get into that chain because they are saturated. Some people might ask, well, what happens at the ends? How does the first bond break? We add a chemical called an initiator to that. So the initiator is usually a very reactive molecule that will break the first bond, and that would join on at this end, and then the other end would pick up the other half of the initiator.